Hi customer service agents, my name is Sarah. I am the product developer at CRI Genetics, and this is the second presentation on the maternal and paternal lineage presentations I've made for you. So in this one, we are going to discuss paternal lineage, so let's get started. Ba-bum. So as we discussed in the first presentation, these mutations for maternal and paternal lineage will all be hereditary mutations. For Y DNA, these mutations are on the Y chromosome, on the sex chromosome, the 23rd chromosome pair. Scientists use these mutations on the Y chromosome to follow male migration patterns throughout time. They've done this through analyzing human fossils as well as analyzing the humans today. Men with similar Y DNA mutations are grouped together to form haplogroups. And as you can see from this picture, you have the first, I say that in quotes and you'll see why later, the first Y DNA chromosome. A mutation occurs, so this got put into haplogroup B. No mutation occurred, so this one stayed A. No mutation occurred, this one stayed A. Mutation occurred on this one, so it became C haplogroup. This one, B mutation maintained, so it's still a B. This one has a B and another mutation, so it became haplogroup D. So this picture is really big, but it shows you a generalization of all the haplogroups and the migration patterns over time. So on the bottom you have the age in years which these movements occurred, and just a general overview of all the haplogroups. So we have 20 Y haplogroups, and you can see from this picture, we have A, which is like the start, the original, B, C, T, and then it goes divides farther on, and etc. So again, 20 Y haplogroups. The naming system is just a letter, A, B, C, all the way to T. To specify even further, there will be a number as well as a lowercase letter associated to it, which we'll see in a little bit. Each branch represents a mutation or mutations that occurred on the Y DNA. The common ancestor for all haplogroups that we know about today is based on a man from 275,000 years ago, and we refer to him as Y chromosomal Adam. Now, a very common misconception is, since he's named Adam, people associate it as a biblical reference to like the first man, Adam and Eve. Scientists just kind of did it as an association, but the implication is that he is not the first man. He is just a man from 275,000 years ago whose Y chromosome was able to travel throughout time with mutations to present day. He's not the first man. At the time, there were thousands of other men and women, and we just should let you know that that is a very common misconception, so don't believe it. So haplogroups. This is an example of a phylogenetic tree. As you can see, that this R1b is a subclad, which is a offshoot of the haplogroups. So the R is the haplogroup, and then the 1b is a more specified version of the haplogroup based on mutations. So as you go down this phylogenetic tree, you start off with R1b, a mutation occurred here on this genetic marker L278, which gave rise to the subclad R1b1. And then we had another mutation here at L754, a new subclad group, and then etc. It goes all the way down, and you can see it through different time periods. So you may be asking, what is the mutation rate of Y DNA over 275,000 years? So scientists have estimated it's about 0.6 to 1 times 10 to the negative 9th power per base pair per year. For some of us who aren't good with scientific nomenclature, I wrote it out here for you guys. So, I mean, it's incredibly low. So do keep that in mind. Mutations do not happen overnight. They're not supposed to happen because your body should be able to fix your DNA when errors occur. But that's how we all become unique, that's how we all become different, and that's how we're able to chase migration patterns throughout time. The Y chromosome has 59 million base pairs. So again, mutations occurring, there's over 59 million. There's a lot going on. There's a lot we can see with this. So again, each genetic marker on the phylogenetic tree represents a mutation or mutations in that specific marker that's differed throughout time, and each mutation brings a new haplogroup, as I discussed at the beginning of the slide. So this is an example of a heat map. So this shows the frequency of a specific haplogroup in an area. So in this example, you can see the darker the color red, the more prevalent that haplogroup is in that area. You can see in Ireland, in the western northern United Kingdom, France, a little bit in Spain, and then we have development here in Russia. And this is for the R1b group. So now if we take this heat map and we put a migration map over it, you can see the changes throughout time, the movements throughout time. So R1b went into Europe as well as part of Russia. And then as all this is also going on, you have R1a haplogroup, which branched off from R1 25,100 years ago and is in between these two groups. So you have haplogroup R1, and then a mutation occurred for R1a and then R1b, and that happened 25,000 years ago. So I'm just trying to, I keep repeating this to give you guys a timeline of like how long it takes for haplogroups to form, for mutations to occur, and even today, new groups are forming that will be considered subclad groups years down the line. The oldest known haplogroup mutation is in the group A00. It occurred about 250,000 years ago, and it was happened over 250,000 years ago. And when you think about that, Y chromosome atom is believed to be 275,000 years old. So the most known, or the latest mutation that occurred happened 25,000 years after the original Y chromosome atom. So you may be asking what was happening 275,000 years ago. It was a completely different world to what we have today. There were woolly mammoths, woolly rhinos, I didn't even know that was a thing, which is so cute, look how cute they are, and tarpons. So keep in mind that how incredible it is, how long we've lived, how long these mutations have occurred, and we've never seen any of these animals. The woolly rhino went extinct 10,000 years ago. The mammoth was believed to go extinct 10,000 years ago, but they actually survived for a while on an island in Siberia. So it's pretty amazing. So this is a table of all the Y DNA haplogroups, the approximate year they occurred, and approximate origin of the mutation. Notice that haplogroup G is believed to have happened 10,000 to 23,000 years ago, and that's when the woolly rhino went extinct. So again, kind of give you a timeline, a map of what's going on in the world. Now you may be asking, so the table I just showed you are haplogroups, but as I keep bringing up, there's these subclads within these haplogroups. So this is a table of the R1a subclad and all the different people who came from this and all the different mutations and all the years they happened. So R1A1, 10,000 years ago, these are where the mutations occurred. R1A1A, 6,000 mutations, etc., etc., etc. And then they all go into these groups within Europe. So we have the R haplogroup, then we have the R1, then R1A, then R1A1, and then it just keeps going down to different specification. But someone who's R1A1A1B still has mutations that occurred from thousands of years ago. So what that last table also showed was how many reports it would take to do every single haplogroup subclad. For example, haplogroup T, the entire T haplogroup only has 70 reported subclads as of 2018. So, that's just one haplogroup, not any of the other 19. As well as there is limited research in terms of qualifications to be considered a subclad. I mentioned a little bit earlier, over time we will be getting more as more mutations occur, but they need to fill certain requirements. Information on migration patterns is not as common as you would think. Scientists are fascinated with this and they're doing a lot of research on it, but not all the science is there. As well as there's many male haplogroups that didn't move out very much or didn't have any people moving in. If you think about Oceania region, the haplogroup pretty much stayed where they are today. There wasn't a lot of movement, and that's also where it developed. So you don't have much migration paths or anything super, super interesting to show because they didn't go anywhere. One thing that's really interesting that they're doing is there's still a lot of indigenous populations, especially in South America, and they're doing research on them, and they're finding lots of interesting things that we all believe that we actually traveled down through Russia, Alaska, and then all the way down the coast of South America. They're actually finding mutations in these haplogroups that don't actually show that. So again, over time, more things are happening. We're learning a lot more, and hopefully know more about ourselves in the future. All that being said, at CRI Genetics, we look at 758 y-DNA markers in order to determine a customer's haplogroup. So that is it for the paternal lineage presentation. So now the next up is the maternal lineage. So see you in a little bit.